So we've recently had a power outage, electricity strike, electricity surge, a lightning strike from using too much electricity. I got a computer, got all these lights, I got a 3D printer, right? I'm using a lot of electricity. And it's storming a lot in Florida, where I live. There's been a lot of storms, recently, hurricane season, right? Middle of summer in Florida. And I knew that this was coming, but I decided to, one day, when everything was like lightning, the storm was passing over, I'm like, why should I, go up and turn all my electronics off during this lightning strike, right? So I just let them on. I'm like, it's not going to hit us. Guess what? It did. It did took out a part of the circuit of this apartment that we're living in right now. And it, we had everything on a surge protector except for the motor. For whatever reason, right? So that's why we have a box right here. We're sending back the old modems that has internal damage because of a lightning strike. And we're sending it back. We got a new one, thank you AT&T. But over here, what I bought to not have this problem again, because I'm pretty sure the problem is my 3D printer, right? It's using up too much electricity. Every time it starts up, it causes that whole entire circuit to go to short. Basically, I have to reset the panel every time. So, but at the end of the day, this is the most boring product I've ever bought, because all it does is make sure you have current, constant power. I know, like, why is that important, right? It's important for things that we go through in life, like this, where this is not the right opening utensil, but basically, this is why we did a thing called a UPS. Now, I'm not talking about a UPS, I'm talking about an uninterruptible power supply, right? This little thing right here. Bought it because it will, it can support up to this much power, right? This is the exact, it's in the exact power budget requirements that can support my 3D printer all by itself, right? So I bought this thing so that power goes out, I could still, I bought this thing so I could still print and continue to print and not trip a circuit when this thing is plugged in and the 3D printer is plugged into this, right? But I can do a test for you real quick to prove my point that every time I start my 3D printer, it will cause the whole entire circuit trip. And then with this device, it won't do that. But I don't know that yet, and we're here to find out. All right, here's some. Anyway, look at this. All right, check this out. So basically what this is a huge battery. And on. This is dangerous in so many ways. I'm excited to bring you guys along on the journey of setting this up. But honestly, at the end of the day, it's just a huge surge protector. That's all it is. You just plug it in. And it's so freaking heavy. Alright, follow. Okay, as you can see here, here's a hefty 3D printer. It uses a lot of electricity. I could even prove it to you that it's going to trip the brake. want to look at the breaker real quick? Basically, when that power is up and we're starting a print, this breaker is going to switch and cancel. All right, so this thing is going to heat up and it's going to flip the breaker. All right. Don't record right now. Let's record.
Piss me off.
What did I do? All right. Recording right? Okay. It should switch any moment now. It's getting close to 247 degrees on the hot end. Okay, and it just switched off the circuit because it drew a lot of current. We're also drawing current to the lights to this workbench as well as that surge protector. We're also drawing light energy to this thing as well. So what we're gonna do is that I'm gonna switch, and like as you can see, it switched this one off. So I'm gonna turn this one back on or reset it, and you can see that every time you try to start a print, it's not going to print. As we see that this device is going to work. You know, and if it doesn't work, and if it can't, you know, completely power or make sure to monitor the power and make sure it doesn't flip the breaker, I could always use this thing for my computer during electrical storms and stuff like that. So basically, what we got right here is this sign will be the surge protector, right? And this sign will be the thing that stays powered on when the battery, when the power is cut off, and it will be just relying on battery at that point. So that's pretty much that. Yeah, you can see the information. And I think honestly it should just be ready to plug and play. Honestly. I have no idea what's going to happen. Is that light switch on?
Yeah.
Are they both on?
Mm-hmm.
Okay. And we are at 121 volts. Battery capacity, current load. There's no current load. We are going to directly power, if this thing can reach. I thought there's probably no protection. This thing is just putting everything on one load. All right, so I'm gonna plug that into here, and now do we experience a load? Probably not, because there's no other lights on this thing except for that Arduino and some LED lights that are powered up. But now I'm going to turn this thing on and see if there's a load. I got still none detected. The power supply on this thing sounds a little smoother, I do say, but again, this screen is third on. Still no current load, but while the bed and the hot end are hot, we're gonna try and do a print, and again, I just took this thing out of the box. It probably still has 50% battery charge, right? That's kind of dangerous, to be honest, to be like transporting around. But I'm gonna just start a print off of this thing, and idealistically, it should just be able to print and not flip the breaker. And I'll just, and we can see already that we already have a current load from the indicator that is displayed right here. We have 2 bars of current load. I think we might see a little more as time progresses. We have already dropped down to 120 volts instead of 121. I think when it cut off last time, we were at around 240 degrees Celsius, and the hotbed is still hot at 667 degrees Celsius. But once the nozzle starts to move and react, we'll know it got past the point at which it flips the breaker. And it should be ready to print right about now, to be honest with you. Oh my God. That's not good. And it just relied on straight battery at that point. So it still flipped the breaker, which is sadness. But another thing we could do is take this load off. Right, reset everything. And it's probably just this, it's just drawing way too much current than it needs to be. Probably needs a new power supply, to be honest with you, but work with what we got. Is there anything has happened to the battery? Not really. But we did know that we did draw a bunch of current, flip the breaker. The 3D printer was completely reliant and powered by the battery of this thing, which is wonderful. So this thing did its job. However, our electrical circuit hasn't done its job. So we need to figure that out. And I'm gonna unplug this too as well, and it's just basically an extension cord at that point. And get a print started. I might need to set the initial temperature of the hotbed to be lower than what it really is during the beginning. Let the motor spool up, get charged, and then increase the hotbed or decrease the hotbed after the print has started. For me, and as my initial set of ideas. But we're getting close again to that point at which it flipped off. 247 degrees. And since we turned off the extra load from the bench power supply, the workbench, it should be able to continue printing. And once it passed the first layer, like tickets right here, that means it has done its job and we are now able to print, and it will not use as much electricity after it's passed that first initial print. So that's great. It hasn't flipped. Good news, we can still use the 3D printer here, and with the assistance of this battery power supply to provide cleaner-ish energy without the extra load, but I guess that's due to the power capacity of the circuit. So yeah,